Okay, today's lesson is lesson number 68. We're going to be translating logarithmic functions. So yesterday we talked about graphing logarithmic functions. Today we're going to continue that, but we're going to specifically be translating them, so moving them around on the coordinate plane. Okay, here are our steps for today. The first thing we're going to want to do is to identify parts of the logarithmic function. And this is our standard equation for a log. So we know the base is b, and then we're going to be paying attention to what's happening with x, and if there's anything being added on the outside. Okay, so if we want to translate a function, we're going to change h or k. Okay, specifically if we want to move it up, we would increase k, and then or vice versa. So if we want to move it down, we would decrease k. Okay, and then if we want to move the graph right or left, we're going to change h. Okay, so to move it to the right, we would increase h, and to move it to the left, we would decrease h. So this is our h here. Okay, that negative sign stays glued to the function. Okay, so that's not part of h. Okay, h is just this number next to it. Alright, so moving on. Actually, what we're going to do is plug in this function on Desmos. So we'll plug this in, just the generic form, and look at h and k as sliders and move them around so that we can see how they affect the graph. Okay, so here we are on Desmos, and this is just our standard form log. I just made it as a log base of 10. So you see if I move h, if I increase h, you can see how it moves to the right. If I decrease h, it moves it to the left. Okay, and specifically, let's look closer at that number. So say I set it at -5. You would notice on our graph, I have this like vertical, I have a vertical asymptote right here, right? So that number here is going to relate to where our vertical asymptote is. So h gives us a vertical asymptote. Okay, and then if we move k, you can see k moves our graph up if I increase it, and down if I decrease it. Okay, so let's see, say if I had x minus 1, so my h is 1, and k, if I had k as, say, 3, we'll see I have a point on my graph at if I go over 1 and up 3, I kind of have a point there, so that can kind of give us some kind of a structure for these graphs as well. Alright, so back to the lesson. I want to try to write the equation of a logarithm that shifts up 5 and left 3. So up 5, I'm thinking, okay, that means I'm going to take k and add 5. Left 3 means I'm going to take h and subtract 3, right? I'm going to decrease it. Then I'm going to take that information to use that to rewrite these logs. So I have h as 1, k is going to be 5 here. So I can rewrite this. This is y equals log base 4 of x minus some number. So let's see, for that number, my original h was 1. I want to subtract 3 in order to shift the graph to the left. So my new h, if I do 1 minus 3, I get -2. So my new h is -2, and then shifting up 5 means I'm going to take k, which is 5, and add 5, which makes it 10. Okay, so that gives me x minus a -2 plus 10. I can rewrite this then, since I have minus a negative, I can rewrite it as y equals log base 4 of x plus 2 plus 10. Okay, moving on to number 2, my h is 2. This is really like plus a -2, so my k is -2. I want to subtract 3 from h in order to move it to the left, and that gives me -1. I want to add 5 to k to move it up 5 units, so I have -2 plus 5 gives me +3. So I'll rewrite this equation. I have y equals log base 3 of x minus my new h, which is negative 1, and plus k, which is 5. I can rewrite this since I have a minus a negative inside the parentheses. This is log base 3 of x plus 1, all plus 3. And those would be my final answers. Okay, so go ahead and write these down. Sorry about that. Take a second and write these in your notes if you missed it. Okay, and moving on, these are similar ideas. So here we're going to be shifting down 6 and to the right 3. Okay, so I'll move k minus 6 and h plus 3. Okay, so my h for number 3 is 1. My k is 4. So I'm going to add 3 to h and subtract 6 from 4. Okay, so doing that, I'm going to end up with negative 4 here and plus negative 2. Okay, so 1 plus 3 gives me 4, so my new h is 4. 4 minus 6 gives me negative 2. Okay, and I can rewrite this, since it's plus negative 2, I can rewrite this as log base 5 of x minus 4 minus 2. Okay, that's my final answer there. Okay, number 4 again, I'm going to look at what's my h. H is 1, k is 2. For h, I'm going to add 3, so 1 plus 3 is 4. And then 2, I'm going to subtract 6, so that'll give me a negative 4. So putting that together, I have y equals log base 1/3 of x minus 4 plus a negative 4, and again plus a negative 4 I can rewrite, so I have log base 1/3 of x minus 4 minus 4. Okay, the next example we did was a graph. So first the same way that we have been doing, we looked at, okay, up, I want to shift it up 5 and left 3, so we created the new equation here. Okay, so 1 shifting left 3 means I'm going to subtract 3, so 1 minus 3 is a negative 2, so this is x minus a negative 2, and then plus I have 3, I'm adding 8 to move it up 5, so that's my new equation. Minus a negative in the middle I can write as x plus 2, so I have y equals log base 5 of x plus 2 all plus 8. Now I want to graph this, and remember yesterday we talked about graphing logs. In order to do that, we need to take the inverse and graph and make a table for the exponential and then flip the values. So I'm going to take the inverse of this. Switching x and y's, I get x equals log base 5 of y minus 1 plus 3. Okay, so I'm going to solve, I want to isolate the logarithm first, so I'll get x minus 3 equals log base 5 of y minus 1. Rewriting this as an exponential equation, I get 5 to the x minus 3 equals y minus 1, and solving for y, I get 5 to the x minus 3 plus 1. Okay, again, now remember we make a table for this exponential, so I have x and y. I'm going to center my table at 3 because that's when the exponent is 0. I'll go 2 units up and 2 units down, so my graph will be from 1 to 5, or my table will be from 1 to 5. Plugging in 1, I get 1 minus 3 is negative 2, 5 to the negative 2 power. Be 1 over 5 squared, or 1 over 25, so plus 1, I get 1 and 1/25. Plugging in 2 here, I get 2 minus 3 is negative 1. 5 to the negative first power is 1/5, plus 1 is 1 and 1/5. Plugging in 3, 3 minus 3 is 0, 5 to the 0 is 1, and 1 plus 1 is 2. Plugging in 4, 4 minus 3 is 1, 5 to the first power is just 5, plus 1 is 6. And plugging in 5, I get 5 squared plus 1, which would be 25 plus 1, or 26. Okay, I'll plot these. Oh, actually, sorry, before, I can't plot these points, this would be the exponential, so remember I have to flip the x and y values so that I go back to the log. So I create a new table here, x and y, I'm just going to flip the values. And then I'll plot these points. So 1 and 1/25, and 1 is about here. Then 1 and 1/5, comma 2, 2, comma 3, and 6, comma 4. 26 and 5 are off the graph. That point is off the graph, so I'll just use these 4 and sketch my curve. Okay, then I want to translate this graph. Right, I want to shift it up 5 and to the left 3, so I can pick any point Okay, and so let's say I pick the point 2, 3, and I want to move that up 5 units, and to the left 3. That's my new point. And then I can also look at the vertical asymptote, right? If I'm shifting the whole graph to the left 3, this asymptote is going to go over 1, 2, 3 units. So my asymptote's here, and I know it curves up and touches that other point. I could also look any other point like this, 1 1/5, comma 2. If I move that up 5 units, and then over 3, I end up right about here. Okay, so all of those points can be shifted in the same way, and you'll end up on the new graph. Alright, so after this we just talked about, we reflected on what we learned today, and did some independent work to review. Okay, that's all for today, so I will see you tomorrow. Have a good weekend.